Hey everyone, in this video we will be deploying a complete Azure AI Foundry environment which will include a hub, a project, and the model itself, and we will use Bicep to do so. We will not use the portal, and also we will not use Terraform because of the state. We will use Bicep because it's the supported way and is an easy way for me to interact with the Azure portal, and also it is a best practice to use this one over the portal because the outcomes from this one can be reproducible and can be easy to automate. If you don't know what Azure AI Foundry is, basically it's Microsoft platform for deploying and managing any AI models like GPT-4, GPT-5, but not only that, but you can also deploy any Claude or DeepSeek, open source models like Llama, Mistral. You can also deploy them, and there is a vast model catalog there. So think about it like having your own OpenAI service deployed in your subscriptions so that you know where your data is. Before we start, there are three things as prerequisites, and the first one is Azure command line install. We will need also the Azure subscription where you will create the resources, of course. It can be a free tier. We will be able to do so just for the demo purposes. And also important that we need the approved quota for the OpenAI model that we will be using, in this case GPT 4.1 mini, in the region that we will be using, which is in this case is US2. If you don't have a quota yet, Microsoft just give it for free. You can just fill a support ticket and it will grant that quota. So first, let's understand what we will be deploying, because AI Foundry has several resources and it's easy to get confused. So everything starts with a cognitive account. This is where the model lives, but not only for generative AI. This is the account for everything related to AI in Azure. It can be speech, vision, language, document processing, but in this case, of course, it's OpenAI, and in particular the GPT 4.1 mini is where this will live. The second layer is the AI hub. This is the management and governance that we will be using. In this part, we will create the connections to the AI services account, and this will grant the access to the project so that the project can reference those models and anything that is defined in the AI service account. Only administrators will work in this hub. The developers will work in projects. So a hub can contain several projects, 1 to n projects. So these projects, or they will reference any model using a connection that was defined in the AI hub. And also, when we deploy this infrastructure, or when we deploy particularly the AI hub, there is three resources that are provisioned by default. Not by default, but it's required to pass them, which is the storage account, a key vault to store the secrets, for example, the connections that we will be doing. And also, if we are planning to use machine learning, we will need managed compute to train the models. So in summary, we will have an AI hub. The hub will contain one or more projects, and the projects can reference any AI service through a connection that was defined in the hub. Something that can be confused is that the AI hub and project don't have a relationship of parent to child. So in the sense of the Azure Resources Manager, they are the same resource type. There is only like a link from the projects to hub, but it is not a child pattern. That's why when we define the bicep, we won't see a nested resource inside the hub. This is the project structure that we will be using. There is the main bicep and the module for each of the components that we just saw. And also to test this one, we will be using a simple Python code to call the model that we deployed to Azure AI Foundry. So the entry point for any bicep is the main file. This is where all the modules are called. So we define the parameters that will be passed through this bicep pattern file. If you understand this, it's very similar to what we had in the R templates before. This is an abstraction over R templates. So that's why the pattern is quite similar. And then inside this one, we can define what is the target scope. We will use the resource group, which will mean that this will require that the resource group already exists. So if we wanted to create a resource group using Bicep, we will need to define the target scope at the subscription level, not the resource group level. And here there is the three modules that we will be calling, which is the Foundry Hub, the project, and the model deployment. And we pass the parameter to each module using this block. Let's start with the biggest module, which is the hub. And this is the one that I remember will define two additional resources, the storage account, the key vault, but also this will create the AI service account. This defines two parameters that were already passed in the main. And here we create the storage account based on this unique string because of the requirement for the storage account unique names. And also similar, we create the key vault. In this case, we are using only RBAC authorization. We are not enabling access policy. And this part is the one that will define the AI service account that I was mentioning before. This is the one that will contain the models, the document intelligence, vision, anything, this is the one that we'll define there. And finally, it's where we define the hub. So the hub here, it's a workspace. We are using a system assigned identity to this one, and it's good that we define this system assigned identity, because remember that we are using two additional resources, which is the storage account and the keyboard. And when we do this, by default, Azure will automatically add this system assigned to the proper group so that it can read and write to the storage account, and also can read and write secrets to the keyboard. So that's very important. If you use a user assigned identity, then you may need to add those manually. And here, this is what I was mentioning before. A nested resource, it will define a child parent relationship. We are creating the connection from this hub to the AI service account that we define here. So this is the one that will consume all the projects, and the authentication is happening through a key, and we are specifying that all the projects can share this connection. The project module is the simplest of all three, and basically what this does is assign a system identity to the project. And this is what I was mentioning before, the relationship between project and hub. It's not a parent child, it's just we specify what is going to be the hub resource ID, and this hub ID is passed to a parameter here. And if we go back to the main and check the project, you see that the hub ID is passed through this output that was defined in this module. And finally, the model deployment module will define first a resource existing, which is similar to a data source in Terraform, which we pass the AI service account name, and we will need this one if we want additional properties of this AI service account. And here, the actual model deployment is where we specify what's going to be the model name, the SKU. In this case, we are using global standard because we don't care about where the data resides. But if you are strict about this one, you can just put zone standard, so that you know that your request will be from one zone, for example, from the United States. And also, this one is very important because we pass this pattern, which is the AI services. That's why we define and this existing resource here. And that's the definition of all three modules. So let's deploy all this infrastructure. So remember that I mentioned that we need to first create the resource group before we deploy the bicep. So let's do that with the AZ command line utility. I'm already logged in, so I'm only going to run this AZ to create this resource group called RG Foundry-YouTube in the EaseUS2 region. Once the resource group is created, we will create a deployment to that resource group using this command. We need to specify what's the resource group that we just created it, and only we need to specify the main.bicep. We don't have to specify the modules, we don't have to specify anything else besides the parameter files. This will take around 2 to 5 minutes, and Azure will create each resource in the right order so we don't have any dependency issues. The deployment was completed. It took about 3 minutes, and it failed the first time because I had in this model capacity 1000. I don't know why. I just changed it to 10 and it worked now. So let's verify that the model deployment that we just did is there with this command. And we can see that the model deployment called GPT-4.1 mini is there in this resource group. So we should be good to start testing using Python. And we can also verify from the Azure portal that we deployed the Foundry, the hub, the keyboard, and this the storage account. And if I just navigate to the project that we have directly, we will see the deployment that we did using another method. Here in the model and deployments, you will see the GPT 4.1 mini deployment. Now let's start testing with Python. This is the basic Python code that we'll be using, and notice that it is the exact same OpenAI SDK. The only difference is that we will import in the Azure OpenAI client instead. So we are passing the API key from an environment variable. Please do not hard code your API keys in the code. Use environment variables, or better, just use a keyboard and reference from the code. And we will be specifying what is the model and the role, the system prompt. In this case, it's just a helpful assistant. And finally, just a user prompt, which will explain what is Azure AI Foundry in simple terms. So I already activated the virtual environment for Python, which only has this OpenAI module installed. And also I exported the environment variables. I will just call the Python file. Just remember to have the right cognitive services endpoint and the key. And this will use this GPT 4.1 mini, and as you can see, it will return what an Azure AI Foundry is in simple terms. So this is how we tested it. And that's it. Easy. You deploy a complete Azure AI environment, and hopefully now you know what an Azure AI service is, a hub, a project, how you can deploy your GPT models, but also any other kind of model that you want, and start using it from your applications. In this case, it was a simple Python application to test this functionality, but this can be as complex as you want. And also the important part is that we use Bicep, and this is a real project that in production it will work with pipelines that will get triggered every time there is a code change in the code. So we don't have to go to the portal and do any manual work. So everything was automated via code. We will have tracking of these changes, and we will be able to, if there is any issues with this ECS2 region, we'll be able to deploy to any other region with no much changes from our side. If you have questions, just drop it in the comments, and I hope you like this video.